All right, for a number to be written in simplest radical form, it means that there are no radicals in the denominator. And it means that there's no common factors between the power and the index. Okay, so when you're looking at these, what it means is if you have 5 divided by 3 root 2, and you cannot have a radical in your denominator. And so you'd have to simplify it. Now, I think did we talk about rationalizing denominators yet? I vaguely I recall that we did, but I'm not 100% certain. And you can use your calculators for these, but you can't have a radical in the denominator. So if you were simplifying this, you would take 5 divided by. Remember, anytime there's multiple factors, and not just terms, but multiple factors in your denominator, of a single fraction, you need to group the symbols. Right? You need to group those together. And so when I write the 3 root 2 here, I have to group the whole quantity 3 root 2 in grouping symbols and put it in the denominator. Okay, otherwise, if I just wrote 5 divided by 3 square root 2. So if I entered this in my display on the calculator, it thinks order of operations would be divide, multiply. So it's going to take 5 divided by 3 and then take that whole thing times root 2. It doesn't know that this is in the denominator unless you specifically put grouping symbols around them. Okay? So make sure you have the right grouping symbols for those. And when we do, we would get the simplified form here, 5 root 2 over 6. Okay, notice now there's no radicals in the denominator. It simplified it for you. Okay, the other rule that's touched on here is no common factors between the power and the index. Okay, in the form of a radical, what that means is, if you had something like this, okay, the 6th root of x cubed, and here our power of 3 and our index of 6 have a common factor, so it's not simplified completely. In order for you to simplify that, and it's easier to see when you convert it into rational power form. So x, the base of x, to the power of 3 divided by an index of 6. Well, what does that simplify to? 3 goes into 6 twice, so you get 1 over 2. And if you rewrite this back out as a radical, we have our base of x to the power of 1 and index of 2. So we can leave it unwritten. And so the 6th root of x cubed actually simplifies into the square root of x. Okay. All right, so try these couple sample problems, please. Okay, on both of these, you're going to see how you have to translate what your calculator shows into what needs to be entered. Okay, so try on your own to see what the calculator shows, and then so you can pay careful attention when I talk through how you have to manually translate that information. All right, so if you type this into your calculator, and you can either use the root form, right? You can type in root 12 over 25, comma 3. Again, root and then your base, comma, your index. Okay, or you need to transfer or translate this into rational power form. If that's the case, you take your base, 12 over 25, to the power of, again, a cube root is just a power of 1/3. So let's enter that in our calculator. So 12 over 25 to the power of, in grouping symbols, 1/3. And notice what you get for your answer. I'm going to write it very lightly here, so I don't know if you can see it or not. But you get 15 to the 1/3 times 2 to the 2/3 all over 5. Okay, now, that is not the way that you need to enter your answer. Normally for this chapter, whatever way they enter the problem, that's the form that you need to write your answer. So they gave it to you as a radical. So even though you converted it into this rational power form to solve it, you have to convert back out. So let's see what we have here when we rewrite this. So our denominator we have. So we know that 5, we've removed the radical from our denominator. Okay, but in the top here, when we look at the two indices, they're the same thing. What does an index of 3 represent? What root? It represents a cube root, right? Whatever the index is the denominator of your rational power, so it works the other way around. So the 3 is our index. And then we look to see what's left after we account for that index of 3. We have 15 to the power of 1 times 2 to the power of 2. So really we're looking at 15 times 2 squared. And we can simplify that. We have the cube root of 15 to the first is just 15. 2 squared is 4. 4 times 15 is 60. And so this is what your answer would be. And once again, the way that you would enter your answer online, you would say cube root 60 divided by 5. And that would be the way that you would enter your answer. Okay. Questions on what I did to translate from what my calculator showed up here into what I need to write online? I guarantee you this will be some of the more challenging things is to try to find what's the right form for those. Okay.
How do you enter it if it's like, if there would be like a 2 by 12, how do you enter it in the root thing? For like number 1, there would be like 3 square root of 12 squared over 25. Like how would you, where would you put the square?
This cube root?
No, if you had like another number.
Like a fifth root of this?
No, like
okay,
in the square root. Is that possible?
If there was another number. Now, so there's no square roots here. You're talking about the radical? Or are you talking about one of these problems up here?
No.
Okay, so here's the thing. So keep in mind, and this brings up a really good point, because this is a square root here. But if it's, if you're comparing this to like any other number n here, it's not considered a square root symbol. It's just a radical. Like this symbol right here is the radical. And then the index is n. So are you talking about another number inside here?
Yeah. Like if it, I don't know how to explain.
Can you give me like an example? How would you manipulate?
Of that, like the 6 square root x.
This one? Yeah.
How would you enter that in the root?
How would I enter this?
Like your calculator.
I would enter it as x to the power of, then the power is 3 divided by the index, which is 6. Okay. So whatever the index is going to be, so this right here, the nth root, translates into the power of 1 over n. Is that is that what you're asking? Okay, thanks for being patient and clearing it up. All right. So let's look at this second example, or this last example here, and it's a little more challenging. Okay, so if you're looking at, again, the 5th root of this whole quantity, and we can enter this, you can either use the root symbols. So if you use the root symbol, you get root x to the 5th divided by y cubed, comma, 5. So that's how you can enter it if you have the updated operating system on your calculators. And if you don't, you need to translate this into a rational power. And here's what we would do. We just take our base, x to the 5th over y cubed, to the power of 1 over our index, 5. And so we rewrite that in rational power. So we take our base x to the fifth divided by y cubed. Take that whole thing to the power of 1 over 5. And when we do, we get our answer. Now, the answer that our calculator shows us, x over y to the 3/5, is this simplified form? Or do we have a radical in our denominator? Now remember, any rational power that's not an integer is a radical. So here we still have a radical in our denominator. We need to get rid of that. So what we're going to have to do is, and this is a case where you do have to rationalize by hand. And the way that you rationalize by hand is you need to make this denominator equal to the base by itself, to a power of 1. So what would you need to multiply this base by in order to be left with just y to the first? Remember, when you multiply two numbers with the same base, what do you do with their powers? So if you go back to the properties we reviewed here, when you multiply two numbers with the same base, what do you do with their powers? You add them. So when we're looking at this problem right here, what can we add to 3/5 to get a value of 1? 5/5. Right? 5/5 is a value of 1. So what do we add to 3/5 to get 5/5? 2/5, right? So we have to multiply the top and bottom by that quantity in order to wind up with y to the 5/5, which is just a value of y. Now we've met the conditions for it being simplest form. And then in the top, we get x times y to the 2/5. Okay, we're still not quite done. Okay, we've simplified it, but now we need to put it back into the form we started with. We started with a radical form. Okay, so when we finish this up, we now need to convert this into radical form. Our denominator stays as it is, y. Our x was not, there's no rational power applied to the x, so it's just itself. But there is a rational power to the y. So when we express this, we take our root, we take our base of y, the power of 2, and the index is whatever the denominator is of our rational power. So 5 goes in our index. So this is actually the form that you need to write this in. X times the 5th root of y squared over y. And so the last thing is to identify how you would enter this online. And so you get x, 5th root of y squared divided by y. Okay? So you can see that this is where the majority of questions are probably going to come, is not how do you enter it on your calculator, but what do you do with that? How do you translate that information and make it useful, or at least in the form that you need to? And so that's really what you're being tested on here.